This is the part of the lecture series on atomic structure, periodic table and chemical bonds. So right now we are going to discuss what is called the shapes of orbitals. We have already learned that there is what is called an s orbital, then there is called p orbital, and then there will be SPD and d orbital and f orbital. And we know s corresponds to L is equal to quantum number L is equal to 0. P corresponds to angular momentum or quantum number L is equal to 1. D corresponds to L is equal to 2. L is equal to 2. D corresponds to L is equal to 2 and F corresponds to L is equal to 3. So having said that, today or right now we are going to discuss this S and P orbitals. So we already know, so corresponding to P, actually there are 3 orbitals. We know that, so there are 3 orbitals corresponding to P. And we will call them Px, Py and Pz. So orbital we know is actually a mathematical wave function. So orbital is a wave function of the electron. And if we have a wave function, we know that from the wave function we can calculate or find out the probability of electron in the space. So we know that if psi is the wave function, then psi into psi star actually gives the probability density. It gives the probability density. It gives the probability density. So and what do you mean by shape of the orbital? Shape of the orbital gives the outline volume in the space where finding the electron is significant. Let me see. So the shape of the orbital is like it encloses the volume in which you can find the electron, means there is a significant probability of finding the electron. So what are the shapes? So for s orbital, the shape is spherical, and for p orbital it is dumbbell shaped. So what do you mean by that? So this is the shape of s orbital. So we are looking, so this is my z axis and this is my y axis and this is my x axis. Okay, and so you can see a sphere. So we are considering electron here inside the hydrogen atom. So the probability of finding the hydrogen atom, the electron, is significant inside the sphere. That is what it means. This is my s orbital. It is spherical in shape. So probability of finding the electron is like it does not depend on direction. So probability of finding the electron here or probability of finding the electron here actually depends only on the distance from the origin. So it has no, so this s orbital has no direction. S orbital, a sphere has no particular direction. It is, s orbital has no direction. It has no direction, but so this is so inside the sphere the finding the electron is significant. outside the sphere, it's negligible. Similarly, we can have, sorry, this is no, this is not periodic table. So this is shape of, so this will be shape of p orbital. Now we know that shape of p orbital, so we just discussed, we know that there are 3 p orbitals. So this is px, we denote them by px, py and pz. So everything like px is a different wave function, py is a different wave function, pz corresponds to a different wave function. So for px, if we find out the probability, we will see that this is a dumbbell shaped. So this is px. So you can see this is dumbbell. There are 2 lobes. So there are 2 lobes. So this is a lobe, this is one lobe, and this is another lobe. So the probability of finding the electron in this orbital px is significant inside the lobe, and outside the lobe it is negligible. So this is a dumbbell shape. So this is dumbbell. So this, all the shapes are dumbbell. That was sphere, it is dumbbell. What was the spelling? Dumbbell. I have to check where it's, I think dumbbell. This is dumbbell spelling is what we should be. So it is actually, the spelling is D-U-B-E-L-L. So here also there is a mistake here. This is actually D-U-M-B-E, dumbbell. Okay. So it is dumbbell shaped. So this is px, this is py. So this is py. So here the axis of the dumbbell is along x. Here the axis of the dumbbell is along y, and here this is pz. Here the axis of the dumbbell is along z, and the reasoning is the same. And so inside this yellow lobe, so we have 2 lobes. Inside the yellow lobe, the probability of finding the electrons is significant, and outside these lobes it is negligible. Here also, inside these reddish lobes, the probability of finding the electron is significant, and outside it's negligible. So we'll stop here, and next class onwards we will study periodic table. So